This video will be about exponential functions. So the first thing we'll discuss is how to graph an exponential function. An exponential function is something in the form y equals a times b to the power of x. So the way this looks is at the point where x equals 0, your graph touches the y-axis at a, and then depending on whether b is greater than or less than 1, the function will either decrease exponentially or increase exponentially. So if b is less than 1, then our function is going to decrease and it'll look something like this. And it'll just keep going down, but it never actually touches the x-axis. And if it happens that b is greater than 1, we'll have a graph that again touches at a, and it goes up. And so on this side here, it also never touches the x-axis. And how steep this line is depends on our value of b. So in this case, the larger b is, the steeper our curve. Now let's see how to go from a graph to a function. So let's say that I'm given a graph with 2 points on it. Let's say one of them is 0, 2, and another one is 2, 4. And so we know that this is an exponential graph that goes through both of these points. What we can do is say y equals a times b to the power of x and plug in the values that we have. So when x equals 0, y equals 2, and when x equals 2, y equals 4. So now what we can do is we can divide these two equations, and what we'll end up with is 1/2 equals, then we have a times b to the power of 0 over a times b squared. Our a's cancel, and we end up with 1 over b squared here. So that means that b squared equals 2, or b is the square root of 2. And then, in order to find a, we can just plug our value of b back into any one of these first equations. So 2 equals a times the square root of 2 to the power of 0, or 2 equals a. And so now we have as our function y equals 2 times the square root of 2 to the power of x. Let's see how to solve an equation that has an exponential. These equations are something of the form where you have a number raised to the power of x equals either another number or another number raised to some power of x. So let's say as an example that we have 3 to the power of x equals 81. In this case, how would we solve for x? What you would do is you take this number here, the 81, and you try to look for a power of 3 that equals 81. In this case, we know that 3 to the 4th equals 81. So what we can do is rewrite 81 as 3 to the 4th. And now, just by looking at our equation, we can tell easily that x equals 4. We can make these equations more complicated by adding an x to the other side. So if we had something like 3 to the x equals 81 to the power of x minus 1, then you would do something similar. So again, we would replace 81 with 3 to the 4th, and then you could use the properties of exponents to simplify that into 4x minus 4. And now we can look at this and say that x equals 4x minus 4 and solve for x. In order to solve an exponential inequality, we can do something similar as we did for the exponential equalities. So recalling our first example, 3 to the x, let's see when 3 to the x is greater than 81. For this to happen, then we have to have 3 to the x is greater than 3 to the 4th, or x is greater than 4. But now here we have to be very careful. What if we had something like 3 to the x is less than negative 27? Well, what we can do here is replace 27 with 3 to the third, as we've been trained to do. But now what do we do about the negative sign in front? In fact, if we look at the graph of 3 to the x, we remember that it looks something like this. And we see that our graph never reaches below 0, and so it definitely never reaches below negative 27, meaning that our inequality here has no solution.